particle p moves in a straight line with acceleration cos pi t meters per second squared at time t seconds. The particle starts from rest at t equals 0. Obtain the distance travelled by p in the time interval from t equals 1 to t equals 2. So it starts from rest at t equals 0. So v equals 0 when t equals 0. And since we're just after distance, let's suppose that it starts with 0 displacement as well. So we know that A is cos pi t, and to get velocity we then integrate. Cos integrates to sine, so that will be sine pi t divided by the differential of the inside function plus c. We know that v equals 0 when t equals 0. So in that case v is 0, sine of 0 is 0, so that means that c will be 0. So we now have that v is equal to sine pi t over pi. Now, I'm going to stop there with a double underline because I know I can come back to this stage here to get an answer, but I'm just going to work through further without the calculator to start with. So, we're interested in the displacement because we want to get to distance. So we integrate again. Sine integrates to negative cos. Divide by the differential of the inside again. And now we know, or at least we chose, x equals 0 when t equals 0. So 0 is going to be, now cos of 0 is of course 1, so this is negative 1. So that's negative 1 over pi squared plus c, and that means that c is 1 over pi squared. So x is going to be 1 over pi squared, and we're going to have 1 take away cos pi t. Now let's think about where v is equal to 0, because that's when it will change direction. And that means that sine pi t has to be 0. So if we think about the argument here, pi t would need to be 0, or pi t would need to be pi, or pi t would need to be 2 pi, etc. So this would give me t is 0, t is 1, t is 2. So it doesn't actually change direction between t is 1 and t is 2. So we can go for x of 1 and x of 2, and the difference between the two displacements will give us the distance. Now remember, we've been doing calculus here. We have to be in radian mode on the calculator. So x of 1 is going to be 1 over pi squared, open bracket, 1 take away cos pi. In actual fact, we should have known what that was to start with. Cos pi is negative 1. So that's going to give me 0.203, correct to 3 decimal places. And then if t is 2, we just need to change this in here to 2 pi. That gives us 0, and so the distance covered is 0.203 meters, correct to 3 decimal places. Now if we wanted that exact instead, we could have done x of 2 take away x of 1, and x of 2, remember if we put that in here, we got cos of 2 pi here, so cos of 2 pi we know is 1 take away 1, so that would be 0 as we found here. And then if we put 1 in there, it would be 1 over pi squared into 1 take away cos of pi, which of course is negative 1. So we'd have got negative 2 over pi squared, and the distance would be equal to 2 divided by pi squared, not multiplied by pi squared. So 2 divided by pi squared. So that's the exact distance. Now if we come back to here, could we have done this with an integral on the calculator? Well, let's go to standard and let's just try it out. So we're going to go from t is 1 to t is 2. I'm going to use x instead of t in the integral. So what have we got? We have got sine of pi x divided by pi. Now, I know it didn't change direction, but if we just put a modulus around that, then it wouldn't matter if it did. It would give us the distance. And there we go, 2 over pi squared.